Alright, so one of the first things that we need to do here is to solder all the pins for the motor shield. And I'm going to go ahead and finish applying a little bit more solder here. Got a few pins that I need to solder. You want to apply the heat to the pad for a little bit and then apply the solder, and it should join up pretty good. There we go. Alright, I think that's all of those. All of those are soldered up. I think that looks good. Not too shabby. That should work. So basically, after you have all the pins off, this is the Uno, this is the motor shield. So I believe what we'll be doing is connecting the primary power and ground to M1, M2 to control the two motors. I need to read a little bit more about the specifications of it. As far as the voltage in, I gotta read up on that. I don't. Oh, there's the power right there. So there's where the voltage in will come from. We'll need to determine whether or not we need this jumper wire or not. We will be plugging in the USB cable here, going to the Raspberry Pi. So we got to make sure that we're not feeding back any power back to the Pi. So check that out. But that's basically what it looks like right there. This is the Adafruit, I think it's version 2 of the motor shield, and that's what's going to drive the robot's movement. Alright, next we have this EMIC 2 board, which is a sound module, and over here we have Arduino Nano, and what happens is we've got it connected over USB and it's plugged into the Raspberry Pi. The Pi can send a serial command over to this guy, and he'll send the signal out to the EMIC 2 to be able to speak whatever it is we want the robot to speak. So this will give us some verbal feedback as we are progressing through the development of the robot, and it's also going to make it a lot of fun. So with that, what we're going to do is, let's see, first of all, we have this speaker, which is going to be replaced with this speaker soon, once I get a small amplifier for this guy. After we do that, then we'll be able to put everything on the robot. And I don't want to put this big brick on the robot. Anyway, over here I'm going to run a program. The software that we're working on, it's going to go out there and identify all the devices that are connected up to the robot, which right now is this motor shield. It's an Adafruit motor shield and an Arduino, and then over here we have the speech module that we just discussed. So it should identify both of these boards, and in theory it should read aloud what devices it has found. So let's see what happens. I'm going to run the program.
Speech module found. Test module found.
There we go. So it found both modules, so that's good. So now we need to start putting some stuff together. I'm going to transfer this off the breadboard into a small PCB that we can mount on the robot. So I'll probably work on that next. Again, I do want to put an amplifier on it so we can use a smaller speaker, but we're going to put together what we can. Alright, what I'd like to show you here is what the robot looks like with the full tread assembly applied. And also over here we've got a few parts that were 3D printed. 3D printed this as a mount such that we can mount the motor driver vertically. Takes up less space on the bed here. As an example, we have a Raspberry Pi that's mounted. Of course, this guy is going to be communicating over the USB port with a small cable that's going to go over to the Arduino. And then we'll have this speech module. Once it's fully assembled, we'll have that mounted along with a speaker and a small amplifier. So we'll have a onboard audio. Over here we've got a battery pack. This will accept 4 18650 batteries, which are running at 3.7 volts, I think 3000 amps or 3000 milliamps each. So we're looking at, you know, pretty good amount of power. It may be too much power, so that's one of the things I need to make sure that I don't wind up frying anything. As for powering the Pi, I'm kind of afraid to use any power coming from here, so I'll probably put a USB bank on it to power the Pi, because I don't want to fry that. It costs a little more than some of this other stuff. So initially when I begin testing, I'll write some software for this Arduino with the motor shield and just get the robot moving before I have the Raspberry Pi actually sending commands. Now the nice thing about the Pi is that it has Wi-Fi built in, and it also has Bluetooth. So what that will allow me to do is to create a socket server that will allow communications to the motor controller, and basically you'll be able to use your cell phone to remote control the robot over Wi-Fi, which gives you a pretty good range of roughly around 300 feet indoors. So I'm looking forward to that. Of course, I got to write an application for the cell phone, which I'll probably write in UI5. It's an SAP UI5. So I hope that works out well. I'm sure it will. If that doesn't work out well, there's other options, but that's my preference, to be able to control it through UI5. It has a very rich HTML5 interface. It's cross-platform, so it'll work on iOS, it'll work on Android, on the PC, and so forth, which would be fantastic. So anyway, that's where we currently stand with the robot.